हेलो स्टूडेंट्स, स्वागत है आपका हमारे डेली के वीडियो में। तो आज हम पढ़ने जा रहे हैं सॉल्यूशंस ऑफ सिस्टम ऑफ लीनियर इक्वेशंस बाय यूजिंग द डिटर्मिनेंट मेथड्स एज वेल एज बाय यूजिंग द मैट्रिक्स मेथड। तो जल्दी से स्क्रीन शेयर कर लेते हैं। आई थिंक माई स्क्रीन इज विजुअल्स टू ऑल। सो टुडे आज की क्लास में देखेंगे सॉल्यूशन ऑफ system of linear equation. First of all, we will see by using determinant or this will be called as the Cramer's rule. So the system of the linear equations, either the system of the linear equations will be in the two variable or it can be the three variable. So in the two variable and the three variable, in the two variable of the system of the equations, it can be derived from that we have already studied in the class 9th as well as in the class 10th. Here we will discuss the system of the linear equations in three variables. So there, if there will be the three variables, so we need the three equations for finding the x, y, and z value, and this is called the linear equations because of the exponent of the every variable, it is only 1. So let me write the system of linear equations. Let the system of the linear equations is a1x plus b1y plus c1 is equal to d1, a2x plus b2y plus c2 is equal to d2, and a3x plus b3y plus c3 is equal to d3. So everything is fine. So this value can be written in the determinant form. Let us assume this one called as the delta. The coefficient of the x, y, z we are writing in the form of the determinant, that is the represented by delta. So the coefficient of x is a1, b1, c1, a2, b2, c2, a3, b3, and c3. Okay, so because here it is the three equations, so it has the unique solutions of x, y, as well as z, or it has the infinitely solutions, or it has the there will be no solutions. So we will check the conditions also, in which conditions it has the unique solutions, infinitely many solutions, or no solutions. Okay, so delta we have assumed this one. So now we will write the delta 1 how delta x, how we can write the delta x. We will replace the x coefficient with the this constant value. So delta x will be the d1, d2, d3, and the remaining terms will be the as it is, means b1, b2, b3, c1, c2, c3. Okay. Now we will write delta y. So we will replace the coefficient of y with the constant quantity, that is the d1, d2, d3, and the remaining will be the same. So a1, a2, a3, in place of b1, b2, b3, it will come d1, d2, d3. When we will solve the questions at that time, it will be clear to everyone. So don't worry about. And we can write delta z, it can be written, replace c1, c2, c3 with the constant value, and the remaining will be the same, a1, a2, a3, b1, b2, b3, and d1, d2, d3. These are the system of the linear equations. Three equations is given, we have written in the determinant form. So if we have to find the x value, so x value can be found by the delta upon delta x, delta x upon delta. Y can be found by the delta y upon delta, and z value can be found upon z, delta z upon delta. Now we will see the conditions, in which conditions it has the unique solutions or infinitely solutions. So the first case, if the delta is equal to 0, if delta is not equal to 0, means this value is not equal to 0, means it has the unique solutions. Unique solutions means x and y has the unique value. If there will be the unique solutions, it is called the consistent solutions. It is called consistent. The system of the linear equations are consistent, and in the other word, it is also called the trivial solutions. Trivial solutions means x and y have the three yeah. It has the trivial solutions, means they are the three variables x, y, z, so it has the unique solutions. In the second case, if delta is equal to 0, so there will be the two cases of the delta, when delta will be equal to 0 and any of any of any of delta x, delta y, and delta z. Wait, for we are writing for now for infinite number of solutions. So for infinite number of the solutions, delta x will be equal to delta y will be equal to delta z is equal to 0. So in that case, it has the infinite number of solutions. Infinite number of solutions. So it has this at least it has the solutions, so it will be called as the system of the equations are consistent, and it is also called, it is non-trivial solutions. So means the x and y and z value will become in the terms of the another constant value, that is the multiple of the k. So it is called also the non-trivial solutions. And in this case, in the third case, if delta will be the same, delta will be 0, and any of delta x, delta y, or delta z is not equal to 0, so if the delta will be equal to 0, it is also the non-trivial solutions, and it has the no solutions. So if there will be the no solutions of x, y, z, so it is called the inconsistent. The system of the linear equations are inconsistent, and it has the non-trivial solutions. So mainly the questions in the IIT, they will ask about the for the non-trivial solutions. Many of time it will be asked for the non-trivial solutions. So if the system of the equations will be given for non-trivial solutions, we will have to make delta will be equal to 0, and in which that there will be any unknown quantity, it will be like lambda. We can find it by the for non-trivial solutions, we can find the any constant lambda value. So we will see the now questions, and it is called the Cramer's rule. By this method, we are solving by determinant method. It is also called Cramer's rule. Okay. So here we will see the questions. Questions is given, solve the following. equations by Kramer's rule. सो हम बेटा कौन से क्लास के हो? ये जो सिलेबस जो मैं पढ़ा रहा हूँ वो क्लास 12th क्लास की है, और जो भी पढ़ा रहा हूँ वो IIT जेई से रिलेटेड सिलेबस है। तो अगर आप लोअर क्लास में होगे इसलिए आपको नहीं समझ में आ रही होगी, ठीक है, तो आप वीडियो पॉज करके भी देख सकते हो, आपको समझ में आ जाएगा। ठीक है। हाँ, so now we are writing the Cramer's rule. Solve the following equations by the Cramer's rule. The equations is given x plus y plus z is equal to 9. Then 2x plus y 5y plus 7z is equal to 52. And 2x plus y minus z is equal to 0. So first of all, we will write using the Cramer's rule, the delta we will write its coefficient, that is 1, 1, 1, 2, 5, 7, and 2, 1, minus 1. Now we will write delta z, delta x can be written replacing the x coefficient of x with this constant quantity 9, 52, 0, and the remaining will be the same 1, 5, 1, 1, 7, minus 1. Now we will write delta y. Delta y can be written as 1, 2, 2, and b1, b2, b3 will be replaced with the constant 9, 52, and 0, and 1, 7, minus 1. And delta z we can write delta z. First of all, we will solve this one. Okay. So what is the delta value? First of all, we will check its solutions are the unique solutions or what. So from here, we can expand along the any rows or columns. So here we are expanding along the first row. So 1 into minus 5 minus 7. Then minus 1 into minus 2 minus 14. Plus 1 into 2 minus 10. So it will be the minus 12, and this one will be the minus 16. Minus 16 into 1 plus 16, and this one will be minus 8. So it will be 12, 8, 20, 20 minus 4. So it is not equal to 0. So it has the unique solutions. It has the xyz have the unique solutions. Okay, so now we will find the delta x. So we will replace the a1 a2 by the constant term 952 151 17 minus 1. So we will expand along the first column, it will be easy. So it will be minus 5 minus 7 and minus 52, it will be minus 1 minus 1. Okay, and the 0 multiple with the 0, it will be the 0 only. So minus 12 into 9, 108. And this one will be minus 2 and minus minus plus. So it will be 4, 104. So it will be also minus 4. Delta x also came minus 4. Now we will write delta y. From here we can find the x value, delta y. So b1, b2, b3 will be replaced by the constant quantity 9, 52, 0, 1, 7, minus 1. So we will expand along the second column. It will be easy. Minus 9, minus 9. So minus 2